Okay, all right. Okay, so quick uh, revision of what we did in the last class. So we are going across with BGP, Border Gateway Protocol, or in other way is a WAN protocol, Enterprise WAN protocol. So this is the RFC code for BGP 1654. It's a EGP. Okay. So this is the RFC. This is a EGP Exterior Gateway Protocol. One of dynamic protocol. Okay, dynamic EGP protocol. Whereas on other side IGP, you have the other flavors like OSPF, EIGRP, RIP, all those things. Okay. So what else have we gone through across? So these are all the key points. So routing of packet AS by AS is all that BGP is expected to do. Okay. So with respect to the numbers, BGP works on TCP, transport transmission control protocol, TCP 179. Okay. And it supports all FLSM, VLSM, CIDR. These are the AD values. There are two types, eBGP and iBGP. We have not gone through each one of them, but let me tell you, iBGP is something when it's a part of single AS. Okay, so let's say this is AS 65,000, and if you have BGP routers, then they form iBGP relation. Okay, internal BGP. Now let's say this BGP is formed between two different AS. Okay, now this AS is 300, and now if I have a router, now if you build a BGP connection between these two routers, they are called as eBGP, external border gateway protocol. Yes, this was one of the contradicting statement which we had discussion in the previous class. So BGP is not just layer 3. Okay, and it's not just layer 4 either. So you can say it's a layer 7 protocol. Okay, the reason is application are gonna initiate the protocol. The protocol is been transmitted by the TCP. Okay, the TCP 179, and it's your IP address which is now forwarding those packets from one router to other router. Okay, so the three layers come into picture in case of BGP. So also we have mentioned it's a layer 4 protocol that sits on the top of TCP. Okay, that's how the TCP comes into the picture. Regarding autonomous system, this is very important in the case of BGP because as we know, it's a WAN protocol. Okay, ISP protocol, the protocol which will run between multiple ISPs. Now, how do you recognize or how do you fix the looping issue, right? How do you fix this looping issue? So your AS number plays an important role in order to fix the looping. Okay, so let's say I have AS 100, I have AS 200, AS 300. So whenever my packet is forwarding from one AS to another AS, my packet is gonna tag with the autonomous system. Okay, so now it's 100 and my BGP packet. So once this packet is moving towards another autonomous system, another autonomous system is gonna get added to my BGP packet. Okay, this is 200, this is 100 packet. Now this is moving towards the third ISP. Now let's say the third ISP is gonna add its AS value. So now you see the original packet which started with 100, it added up, the 200 got added up, and later on 300 got added up. So this way your packet are identified via AS number. Okay, and this cannot come back because this has a tag of 100. Okay, as soon as this reach over here, this is gonna drop it. Okay, it's gonna drop it so that there is no looping happening in this kind of environment. So that's why AS plays a very important role. Now there were two types of AS that we learned. It was a 16 bit and 32 bit. Okay, so 16 bit range between 0 to 65535, and later on with the as soon as this got exhausted, we started up with 32 bit, which is also called as 4 byte ASN number. Okay, and this range in this value 2 to the power 32, which is a huge number, but this is the number. Okay, so that's how ASN number was being advanced, and that's little bit about the AS value or ASN number. Who allots ASN to organization? It's by INA. So this is all been covered. There are two types of AS number. One is public and private. Okay. So who is gonna give private and who is gonna give public? So if you know, we talked about RIR and LIR. Okay, LIR is local internet registries. Okay, and these are regional. So let's say they are huge investor on those fiber. So let's say examples like AT&T, Verizon, okay, Tata. So these are called as regional, or on a ISP basis. Whereas these local internet, they could be on city level, okay, or a town level. So basically they purchase a line from the main guys and then they sell it for a cheaper rate. Okay, so these LIR provides you private autonomous system, and the public ones are mostly given by regional. Okay, so when do we use private and when do we use public? So let's say this is my LAN, or this is my company XYZ. I just want to connect to one ISP. Okay, no other ISP, only one ISP. Might be this ISP is then connecting to my XYZ branch office. Okay, there's no other ISP, just one ISP. So basically now there gonna be no more than two autonomous system, one over here, okay, and other one over here. So basically whenever your packet uh, is traveling towards ISP, it's between just two of them. So in such case, we can make use of private. When is public being taken, or when do we need public? It's when your packet is moving towards couple of other autonomous system. Okay, so in this case, you cannot go with private. You need to take public, and that's a little bit on those two things. Okay, private and public, and this was the ASN table, which is regards to the reservation. Okay, so for public we have couple of reserved, for private we have a dedicated block reserved. Okay, so basically the ASN values are in a block segment. So INA, what it does is it's gonna create a block segment and give it to RIR, and then RIR will distribute it to customers and the LIR. Okay, so that's how it works. So you can see the blocks. So for private you can see see, this is a reserved for private in 16 bit. Similar way, you also see private being reserved in case of 32 bit. Okay, so rest are like these are public, and you also have public ASN, public ASN. So that's how the categorization happen in the case of ASN. These are few frequently asked questions, like when to be used AS, when is public AS required. Okay, so these are few frequently asked question which we had discussed in the previous class. Okay, and then we moved towards 4 byte ASN. Okay, so I will include ASN later on. So basically this is 4 byte ASN, which is 32 bit. So it's 1 byte equals to 8 bit, and 4 byte is gonna be 32 bit. Okay, just a calculation. What is the range? It's 2 to the power 32, which is equivalent to this. Okay, anything from 0 to this is the complete 4 byte ASN range. Now let's say someone who is already running on 2 bytes. Okay, let's say one of your customer is already running on 2 byte, and now you have your brand new company which is running on 4 byte. Okay, so don't worry, they are backward compatible. Okay, so how are they backward compatible is something which we discussed in the previous class, but I'll quickly revise that. So there are three ways of writing 4 byte 4 byte ASN. It's AS plain, AS dot plus, AS dot. Okay, so AS plain is in the decimal format. So this is how you write AS plain, the decimal format. Now the same decimal format can be also written in AS dot format. Okay, so what do you understand by AS dot plus? Basically it consists of two orders. One is called as left or the lower order value, which is on your left side. So let's say lower order value, and on your right side you gonna say higher order value. Okay, it starts with this. Okay, 0.0, and all your till your 65535, you will see in something in 0 dot order. So let's say you have 1 ASN value 1. Now the equivalent is 0.1. Let's say you have ASN equals to 100, that becomes 0.100. Okay, you have ASN 1000, now that becomes 1000. So till which number do we see this? Till 65535. This is gonna be 65535. Okay, so you will see this till this number, the 16 bit range. Once the 32 bit starts, okay, immediately the next one, which is 65536, you will see it starting from 1 dot so and so. Okay, it will be 1 dot so and so, 1 dot. So that's the concept here. So it will be it will look like 1.1. Okay, so as soon as we go to 6553 of 536, the next value. Okay, so it's gonna change, it's gonna be 1.0. Okay, the next value 65537, it's gonna be 1.1, and so on. Okay, and for your easier understanding, I also have given you one of the converter. So ASN converter. So let's say you have a ASN value in a 16 bit. Okay, 60,000. So do you see the lower order is starting from 0 dot, and you have this coming up after the decimal notation. Now you take anything in the 4 bytes or 4 byte of ASN, add one more 0. Okay, which is more than 65,000. So if you convert this, so you will see the change in the notation. Okay, so 0 to 65535 is gonna have 0 as prefix, and then anything starting from the next number 536 till your last value, which is 2 to the power 32, they're gonna have anything other than 0. It could be 1, 2, like 1 dot, 2 dot, 3 dot, 4 dot, 5 dot. So let's see the last number. Okay, so what is the last number in 4 bytes? So this is the last number. So if I convert this, so you're gonna see the last number in AS dot plus. Okay, so that's the reason we have the backward compatibility. The 2-bit can also be converted easily, and the 4-bit or the 4 byte can also be represented in the similar notation, so they understand what is what. Okay, and we also see a mixture of 2 bytes and 4 bytes, the backward compatibility uh, concept. Okay, so that's called as AS dot. So three types of representation: AS plain, AS dot plus, and AS dot. Okay, regarding ASN allocation policies, so till 2007 the ISP used to give us 2 bytes of ASN number. Okay, anything from 0 to 65535 basis on private and public chart that we referred. So it was 2 bytes till 2007, and 4 byte used to be only optional or when you request for it. Later on in 2009 it was vice versa. So something like uh, 4 byte was by default, 2 byte was given only if you requested it. Okay, something like in a reverse direction. In the first case it was 2 bytes which was given, and 4 used to be on request. Okay, later on, after like or in 2009 it was in a reverse direction. 4 was to be default, and 2 used to be optional or whenever you request for it. Later on in 2010 or after 2010, they only give 4 bytes. Okay, they only give 4 bytes, and we don't have to worry because of the AS dot concept where it has the backward compatibility. So for example, if an ISP called level 3, okay, if it's aware of one of AS value which is in 16 bit ASN. Okay, now what happens in the third scenario is the ASN value will be just converted to the AS dot. Okay, so let me convert and see what is 3356 going to be. See, so this is in a 4 byte notation. Now let's see any latest company, whoever is trying to build WAN connectivity with respect to the second one, they don't have to be worried that this is on 2 bytes and I am on 4 byte. There will be some compatibility issue or nothing. So there's nothing. Okay, your AS3356 is read as dot 3356 in case of 4 bytes. Okay, and this will have its own ASN value. Okay, so that's how they form neighborship. Okay, and then we went through peering state. There are a couple of peering state happening. So first one, ideal, connect, active, open sent, open confirm, establish. Okay, and across on each one of them I have added couple of lines after the previous class. So these are few lines which I added up today. Okay, just to make it more easier. So ideal and active are two bad examples. Okay, so let me show you the flow chart. So let's say when two BGP start forming neighborship, okay, they look for neighbors. That's the first scenario. They are looking for neighbors. So those state is called as ideal. Now this can have two meanings. The first meaning, when two brand new BGP routers are trying to form neighborship. So yes, ideal is by default, yes, acceptable that they are brand new, the process was started and they are looking for neighbors. It can also have a second meaning. The second meaning is it was an active running BGP routers, and all of a sudden the neighbor went down and now they are on a ideal state. Okay, and if you read the meaning of ideal, looking for neighbors, now that could be bad example, right? When a existing BGP connection, if it all sudden goes to ideal, that is looking for neighbors, so that means there was some change or there is some problem in your network, right? So two meanings for ideal. So I say ideal and active are two bad examples. The same thing goes with active or as well. Active is when it's trying to establish TCP connection, right? It can have two meanings. One is when it's building up a new BGP connection. So fine, that it's under active state, and if it's all good, it will go to the next step and it will get established. Now let's say one fine day you see the neighbors are on a active. Okay, and what is the meaning? It's trying to establish. Now that could be a bad example. It could be, might be you don't have the proper TCP 179 getting communicated, or might be you have a ACL, which is access list, which is blocking 179. So there could be different meaning for that. Okay, so these are two different things, and yes, we see these in the routing table as well. When you go and check BGP neighbor table, so you shouldn't see anything under idle or active. That's not a good example. Okay, that's more or less when your neighbors are trying to establish a connection or they are forming a neighborship. Okay, so under ideal, it's admin down. When the process is admin down, BGP process is waiting for the next try attempt. It's just configure on new neighbor. That's what I told the first scenario. Already established BGP peering is reset. Now this is the second condition. First is when it's a new brand BGP relation. Second, it's trying it has been reset or it's forming a neighborship. So it can have a different meaning. So depends on what kind of scenario you are referring your BGP neighbors. Okay, so depends on that. So what is the second one here? Connect. Connect is when you're trying to initiate the TCP connection with local peer. Okay, so in this case, BGP process is waiting for the TCP to get established. It's waiting for TCP three-way handshake. If successful, it will continue to open sent state. Open sent is this. Okay, this is a state when TCP session was established. So you can see they have some relation. So when it's on a connect state, connect is when they have sent the TCP connection and they are waiting for the they are waiting for the three-way handshake to get completed. Okay, so this is a process where it's waiting for three-way to get successful so that they can start sending their open packet or keep alive or whatever. Okay, so if it fails, see, if it fails, then it's gonna get stuck on active. Okay, so you need to understand flowchart for this. Without flowchart, it's little complicated to understand. Okay, so let me say BGP was just started. Okay, it is in idle mode. From idle mode, it's gonna do the it's gonna go to connect. Connect will do three-way handshake. If it is successful, it is gonna go to open send. Open send is a state where TCP was done and now it's sending the open message. Okay, but if it wasn't successful, if the three-way handshake wasn't successful, might be the port 179 was blocked. Now it's gonna go to the active state and active will go back to idle. So that's why I say this is a bad and this is a bad, too bad person in case of BGP peering. Okay, So connect, yes or no, depends if it's going to be successful. So let's say it was, the TCP 179 was successful, three-way was successful. It will send to open send. Open send will now send a open message. Okay, so let's see what is open send is going to do. So TCP session connected, it's gonna establish peering. Okay, if the TCP connection exists, the router has sent a BGP open message. The open message has not been received from peer. BGP will be waiting for open message from the peer BGP neighbor. So open sent on one side is successful, TCP is successful, okay, and it has sent open message to its neighbor. Now it depends on the second person now, whether the second person is uh, able to form the neighbor or no. Now depending upon the second person, the next step will be taken. If, let's say, the second person was successful in sending open message to, now that state will go towards open confirm. If not, your first router is gonna be placed under active, that is trying to build the TCP. Okay, so in this step, it's more about response from the neighboring guy. Okay, if neighboring guy is down, so you will never get any message, right? You're not going to get something. So it depends on your neighbor. Okay, it has sent message not received, open message not received. Okay, so open confirm is when you are going to send keep alive. Both routers have sent and received open message. Now it's time for keep alive. Keep alive is just to keep uh, the two neighbors up. Okay, they are up and running. So in case if there is one router which is going down, the BGP peer will go down. Okay, so that's a like relationship between two routers to keep them alive. So we make use of a dedicated message called keep alive. Okay, if keep alive is received, it's more move to established. BGP will keep sending keep alive message. Fine. So once after open confirm, it's gonna go to establish. Establish is when all the parameters are matched. Okay. The BGP can now exchange update. The agency is complete. The packet like send update packets are sent. Okay. All the whole timer values or the timer are being received, and all other the parameters of established. Okay, they are complete agency now. They know, they have shared their updates. The second router has also shared the update. They know the whole timers, what is the whole timer. Okay, so something when they both are agency, like in case of OSPF we call. Okay, regards to BGP message type, four messages. One is open, update, keep alive, notification. Open is when TCP was just established and now they are sending a open message to form the agency or neighborship so that they can share their routing update. So basically, what should be matching, or what should be the what would be the component of open message? Okay, so if I say the three-way handshake was successful. Okay, so let's assume the three-way was successful. Now open message would be sent. The second thing would be open message. So these open message are gonna carry these values: autonomous system, router ID, and hold timer. Okay, so once after that, once open send is done, open confirm is done, once they are established, later on you can see the update packets. The update packets are when the two routers are gonna share their routing information. They can include new routes or any deleted route, and also the path attribute. So there are like 11 path attributes, and we usually divide them into four segments. Okay, like well known, well mandatory. So we'll come across that. Okay, and all these four components altogether they are gonna have 11 different attributes. Okay, so attributes are like your policies. Okay, so let's say in case of firewalls, or let's say in case of routers or any switch, okay, how do you write a policy? With the help of access list, right? So let's say you want to allow packet A. So you say you write access list and you say permit A. That means this packet is authorized to uh, authorized within this router R1. If I write a access list saying deny that, so that means router 1 is going to drop that, because I have written a policy saying that allow so and so packet, deny so and so packet. So that's something called as policy, right? Similar way, in the case of BGP, what is BGP? BGP is a protocol. Okay, what is it doing? It's, let's say I have ISP1. Okay, I have LAN 1 on my left side and I have LAN 2 on my the right side, on my right side. If you want to communicate between two different LAN, might be this is in some location, might be India, and this is in US. So how do you send the packet? Over on ISP, over on internet. Who will push the packet or who will advertise the packet? So let's say this LAN network consists of 1.1.1, and over here you have 2.2.2.2. So how are you gonna advertise this to this ISP, so that this ISP can re-advertise or send those 1.1 to the second LAN? Okay, that's gonna be a complete communication between two LAN, right? So it's your BGP protocol. BGP, what it does, it's gonna advertise your packet. So all your packet from your LAN, it will place to ISP, ISP will then place to LAN, and that's how they form the complete end-to-end connection. Now let's say I am not very happy with this ISP. Okay, all of time this ISP has some cable cut, or let's say this is very slower and I am not able to achieve my day-to-day activities, right? So what I do, I purchase another ISP connection, a better link. Okay, and I have a better path. Okay, so let's say now this act as a active and this act as a backup. So let's say that's the scenario. Okay, so now you can have multiple combinations. For example, one combination would be, I will send all my packet over on active only. ISP is just standby. Okay, when this goes down, then make use of the backup to reach to the LAN 2. Until or unless active is up, don't touch the second link, or don't touch the backup link. Okay, make use of only this link always. This is first scenario. Okay, now the management would be thinking, why should I keep one ISP on a idle mode without making use of ISP, the backup ISP, because after all they are gonna spend a lot of money on those ISP as well, right? So they will suggest to the technical team that try to bring some networks. Okay, some non business critical network, some servers, so that it can take the second link. So basically you have 80% of your network going on the first link and remaining 20 going across on your second link, right? Now all these can be achieved by path manipulations. Okay, it's something which you have to do it on your enterprise routers. You are not a ISP guy, you cannot do anything on ISP. Okay, so you need to do it on your end, on your routers. You are gonna say so and so network take this path, so and so network take the other path. Okay, That is path attribute. That is why BGP is different than all your other protocol like OSPF, your EIGRP. Okay, so these protocol will not be able to do path manipulations. They run the algorithm, they will find the shortest path and they will forward the packet. But let's say I have some customization to be done. I want my network 1.1.1 to go via the backup path. Okay, I don't want that to be going through the shortest path of what our OSPF does, right? So that is why BGP is different and it's very advanced, where you can advertise each packet on a different path. Okay, similar way it depends on receiving side. Let's say I have LAN 1 and this LAN has two ISP connection, let's say 1 and 2. Okay, so you can also receive the internet, okay, or you can also receive it from ISP 2. So that's also been possible. So you can manipulate two types of packet. One is a packet which is going outside and the packet which is coming inside. Okay, so these are all done via path attributes, so which will be taken up in the future classes. So in your update packet, path attribute is one such component. Okay, so basically when you see the update packet, the BGP update packet, it's gonna carry this information also. Okay, so we will see in much more detail, and I'll also do a lab so you guys can understand this. Okay, keep alive, yes, between two routers to make sure they're up and running. Notification is when if this goes down. Okay, and then the packet will be initiated to let the second person know that this is down. Now that is over on notification. Okay, so when a problem occurs and a notification will be sent. Fine. And we did a small lab in the previous class, so I'll continue the same lab today with additional topics. So I have my lab here, I have my routers. I'll reload them so that I can start from fresh configurations. Okay, so I have kept very minimum configuration at this moment. Okay, they should have only the interface, nothing else. So if you see, they only have the interface configuration, which is also visible on the screen. So for loopback, okay, this IP I might change it to little realistic one. Okay, so that's why I have not written here, but let me write it now. I'll make it little more better so that it match with the router number. Okay, otherwise 209 and 26 doesn't have a meaningful appearance, so I'll change that while doing it on the workbook. Okay, so this has interface configuration. What about this router? The three interface, so two physical interface and one loopback interface. What about the third one? Show IP int brief, exclude unassigned. So one physical interface and one loopback. Okay, so how do we configure OSPF? How do we configure BGP? Okay, so I go to router BGP. What is the autonomous system? So I have mentioned over here, this is an autonomous system. Okay, autonomous system over here, or the AS number. So I say my own AS value is 65,000. The first thing over here is to add the neighbor statement. So neighbor is nothing but, So let's say from this router point of view, this is my neighbor. Okay, so I'm gonna mention the IP of that. So 209.165.201.2, and I'm going to say that it's on autonomous system 65001. Okay, the second autonomous system here, the Vodafone, is 65001. Okay, fine. So I don't have any further neighbors, but yes, I have one loop back which I want to advertise. Okay, so this advertisement should be done with the command network. So two things, one is neighbor is different, and network is different. Okay, neighbor is peering, you're forming the neighbors. Network is advertising. Okay, so what is happening is these prefix or these network are now sent on this link. Okay, so can you send if there wouldn't be any neighbor? Will you be able to send this? No, right? So until or unless you have a successful neighbor, right, you cannot send any network over on this. Let's say you had multiple networks, so you cannot send them, right? So first you need to build neighbors. That's why I went with first neighbor command. Once they form neighbor, now I can advertise n number of routes. It don't have to be only one, it can be any network. Okay, there can be 100 of network in my office. Okay, which I want to advertise over on this. So neighbor should be the first criteria. Okay, so now I will advertise my network. So let's say my network is 209 209 209.0 mask, and I say 255.255.255.0. Okay, just three lines. One is this neighbor and network. Let me go to the second router, which is on the different ISP. Okay, the first configuration was on AT&T, second one is on Vodafone. So on Vodafone I say interface E0/2. Okay, so interface is configured, I don't have to do that. So I say router BGP 65001. Now I'd say the neighbors are 209.165.201.1. What is the remote AS? Okay, so the remote AS is 6500. So if you see now, okay, I think I have added an additional AS, additional 0 on the top line. Okay, so that might lead to non-neighborship formation, because here I considered this, and if you see here it's a additional 0. So that is, so this will make non-neighborship relation. Okay, so your AS should match. If you have a wrong AS, then that will not bring up neighbors. So I'm going to delete this. Okay, and now I'll do a fresh configuration, router 65001. I'm first defining my neighbor. My neighbor is 209.165.201.1. We have already done the debug things, but I can re-enable. I can also re-enable Wireshark to show you what is happening. Okay, so I go to the second router. This is my neighbor. I say remote AS and 6500 on the other side. So if you see now, on my local router, it's this as AS. Okay, whereas on remote I have this. So two different autonomous system. Okay, they form eBGP. External BGP. External BGP is between two different AS. So this is the configuration for eBGP. If it was iBGP, what should have been it should have been similar. Let's say this is 65,001, this should have been 65,001. That is the case of IBGP. EBGP, two different autonomous systems. So I say this is this, okay. But for this router, there is one more neighbor. If you see, there is one more neighbor on the right hand side. So I'll do the configuration for that as well. But that's on this AS. Okay, over here, I'm going to do the second IP. So what I'm trying to do is, so I'm right now on this router. I have done EBGP configuration. Now I'm trying to do IBGP configuration. Okay, so it's not about writing EBGP and IBGP that will make it look different. It's your AS number. Okay, two different AS number, EBGP, that's gonna called as EBGP, two similar AS, that's gonna make it IBGP. Okay, so don't be in the impression that EBGP and IBGP has to be selected on a drop down, or I'm gonna write it's a IBGP, or I'm gonna type it's EBGP. It's not that way. Okay, it will be automatically picked up by seeing your AS that you define in your configuration. Okay, fine. So after doing this, my two neighbor statement, one on my left side and one on my right side. So on my left side, this is the network that I would like to advertise. Okay, so I say 0 mask 255.255.255.0, and I also have one network on my right hand side, 10.172.13.1 mask 255.255.255.0. Okay, so there is a small mistake. Fine. So Vodafone 27 configuration done. I have the third router now. Okay, I go to router 3. I say router BGP 6500. Sorry, I once again added up additional 0. So it's this. Okay, what is the neighbor now? So neighbor is 10.172.13.1.255.255.255.0. Sorry, neighbor is not subnet, it's remote AS, and it's 65.0.0.1, and then the network statement. Okay, so whatever network I want to advertise. So do I have any loop back in this? Okay, so there is a loop back. Okay, so that act as my network. 1.1.1 0 255 255 255 255.0. Okay, so we have done BGP on 3 routers. Let's check the tables. So you see show IP BGP, you see show IP BGP summary, you will see show BGP neighbors. Okay, these are 3 important configurations or 3 important tables. Okay, okay, so okay, let's see what is not advertised. So I have 10.13 advertised. Sorry, 1 dot network advertised. I have 10.172 and 209 left and right both advertised. Show run session BGP. Okay, so I also have to advertise the loopback. Okay, so okay, loopback is advertised. Fine. Okay, so let's see the tables. Okay, let's see the 3 tables. The first table is show IP BGP summary. So if you see this table, this will reveal us the neighborship. So AT&T 26 is in relation or in a neighborship with the Vodafone router with IP 2012. It's running on BGP version 4 or BGP table version 4. Autonomous system of this neighbor is this. These are the message sent and received. This is the table version. These are the queues. So it should be 0. That's a good example. The queue shouldn't be increasing. If queues are increasing, that means you have a problem forwarding your packet out of that outgoing interface. Okay. So the more queuing number happens, the packet will start gradually getting dropped. So this shouldn't be increasing. It's 0. That's good. This is the uptime. And if you see, there are two prefix learned on this particular router. Okay. So what are those two prefix? So let's see. So if I do show IP BG route, so you can see there are two prefix that is being learned, right? One is for one series network, and second one is for 10 series network. So where are these two networks? So basically it's from this router point of view, this is gonna be one first prefix. If you see 10 dot so and so, and on the loop back you have 1 dot 1 dot. So that's the two BGP prefix. Okay, in BGP we don't call it as subnet or network, we call it as prefix. Okay, so prefix in BGP is nothing but those networks. So how many prefix are we learning? It's one and second. So basically on this, on my show IP BGP neighbor table, I see two prefix are being learned over on BGP routing. Okay, these are the two prefix. Similar way, there is the second table which is called as forwarding table, which is show IP BGP. Okay, from this point of view, if you see, okay, from this router, the second table now is called as forwarding table. It's not a routing table, it's a BGP forwarding table, or you can say BGP engine. Okay, so all your routes will be first in this engine, and whichever is the best path will be then put up inside your routing table. Okay, if you see this angular bracket, so that means they are inside RIP or inside routing information. Okay, if you see them only asterisk mark without angular bracket, then that's just a best route, but they are not within the routing table. Okay, so what comes first is your neighbor table, second is your BGP or forwarding table, which will have all the prefix, and the best one will be put up in the routing table. Okay, so this is the second table now, and what is it going to show us? So it has BGP table version, it has local router ID, which is RID. Okay, these are all the status code of this table. These are the indications. Okay, if you see asterisk, that means it's a best path. Okay, if you see this angular bracket, that means it's present in the RIB table. These are the destination network. Okay, so from this router I am learning 1.1.1.0/24. So what is my next hop gateway? Next hop gateway in BGP is for the next immediate router. Okay, so let's say I have one router. This router is connected to two different routers. Those routers are then gonna connect to the other router, and I have the final destination router here. I want to send a packet, okay, in BGP protocol. So let's say my packet from here enters this router, and the router will know a best path to reach the destination, right? It could go via this or it could go via this. Now this router will see what is the next hop. Okay, next hop is one where this router is gonna send the packet or is gonna forward the packet. So the IP address of this, so let's say this is 1.1.2, will be now acting as your next hop. Okay, so if you see this next hop, it's dot 2. In my scenario, this is dot 2. Okay, the next immediate router or next person who will send who's gonna be forwarding to the destination. So in my case, to reach 1.1.1 network, from this point of view, who is gonna be forwarding? It's gonna be this person. Okay, it cannot be this, it cannot be different, or it cannot be someone else. Okay, the next hop will be the rightful person. So in this case, it's gonna be this interface. Okay, what about 10.172? It's again this. What about 209? It's 0.0.0.0. The reason is they are directly connected, right? They're directly forming a neighbors, or they're directly connected. They don't have to depend on a next hop. So anything you send, it's gonna be received by this person. But if you're going to send anything to the router C, who is gonna receive? It's your router B that's gonna take the responsibility of receiving, right? So these are two different behavior. So when they are directly connected, so take it in this way, when they are directly connected, the next hop is gonna be this. That means if you see this, that means they are directly connected. Okay, if in your network protection, while doing show IP BGP, if you see this has a next hop, that means they are directly connected. Whereas these are far away destination, and they are dependent on this router to forward those packets. They can be uh, 2 hops away or 3 hops away. We never know. But who is my immediate neighbor? That is this person. Okay. Now I can log into this person 209.165.201.2, and then I can do show IP route to see is it directly connected or it's still connecting to some router, and then so and so. I can then connect to the third router. I will see show IP route for this network, and might be it's a directly connected now. So that's why there are 3 hops. This router don't have to know this router. Okay, in BGP, they don't have to be directly connected. So they don't have, let's say, BGP router A and BGP router C, they don't have to know each other. BGP router A must know the immediate router. That's the next hop. Okay, and that can lead to some issues also, which I'll tell you in few minutes. Okay, so if you see 2 far away hops, you will see next hop. When they are directly connected, your hops would look something like 0.0.0, because they don't have to depend on a router. They are directly connected. Now metric, local preference, weight are, and also path are your BGP attributes. As I told you, there are like 15, okay, or let's say 11 to around 11 to 15 attributes, because depending upon Cisco, depending upon Juniper, there are little here and there. So usually they are like 13 best selection or parameters. Okay, you can also call it as parameters. So like this is one parameter, second parameter, third parameter, fourth. So we will talk this in a separate class, not in the class today, not in today's class. So metric, as usual, is a cost value. Okay, so you can see the cost value is not defined, because in BGP cost is not a factor to be considered. It's your path manipulation. Okay, so these are the components that gets manipulated to change the uh, path reachability. Okay, in case of EIGRP, in the case of OSPF, we learned its cost. If a path, if the cost is less, it's gonna take that path, right? But in the case of BGP, it's not the cost, it's the path manipulation attributes, that is around let's say 13 attributes. Okay, so these are the attributes that is gonna tune BGP. Whereas in case of your EIGRP BGP, it was cost, completely cost, right? Whereas in EIGRP you still had some factors like bandwidth, delay, load, but the formula was leading to cost, right? You had different components, but it was leading to cost after all. In OSPF, it was cost, but in BGP, it's not going to be cost. Okay, cost is not important for me. It's the different attributes that's helping me. Okay, so local preference, nothing set by default. They're gonna be 100. If you see the weight, so this weight is a Cisco proprietary. You will see this attribute only in Cisco. Okay, so whenever two BGP routers are learning a network or learning a prefix uh, over on a next hop, okay, by default they are gonna take weight of 0. So if you see weight 0, that means they are remote remotely learned networks or remotely learned prefix. But if you see 32768, which is the default value for weight, that means they are directly connected. Okay, so whenever you have two directly connected, you will see weight will be 32768. But if you have these network, the network on the C side or router C side, so those will have weight as 0. Okay, that's a default behavior. That, so I can frame in this way: two directly connected or locally connected BGP will have a weight of 32768, but when you have remotely learned prefix, then the weight will be 0. Okay, in such scenarios your AS path plays an important role. So let me tell you what is the relation between weight and path. Okay, this path is nothing but AS path. Okay, autonomous system path. So let me tell you what is the relation between these two. If you see, when weight is 0, it's having some different value for path, but when weight is, there is some value for weight, the AS is gonna be like null or 0, right? So the reason is, say let's say when I have two autonomous system, let's say this is autonomous system 1 and this is 2, and this is my router 1 and this is my router 2, and I also have one more router within this, which is router 3. So these are two directly connected, right? So these are two directly connected. So in this scenario, weight is seen 32768. AS value is not a important thing here because they are directly connected. They are, the packet is just within these single AS after all right? They are single movement. But when your packet is traveling, or when your packet is getting forwarded from one router to other router, that is when your AS will get added up. So I told you, when I have a packet over here, if this packet is arriving on this, okay, now it's gonna add the AS value like 6500 and packet, and then it will forward to the third person. It will add its AS value, it will forward further, and so on. The AS value gets added up, right? So when you have hop by hop, it's your AS that's considered, okay, in this scenario. Whereas they are two directly connected, when there is no much involvement of AS, it's your weight. Okay, weight is actually locally significant. We will come across that, don't get confused. Okay, it's weight and it's AS path. This is AS path. Okay, I refers to internal, it refers to the internal prefixes. Okay, the next or the third is BGP table, or the routing table. Okay, so if I show you the routing table, so these are all locally connected or directly connected. These are the two which are learned over BGP. So you can see the protocol code BGP. So this is 1 series and 10 series. Okay, 10 series and 1 series. So so what do I have in this? Okay, so if you see here, it says 3 best prefix and 3 best prefix in routing information with the angular bracket, right? So if I see my routing table, okay, so I can see them, all the 3 of them in the routing table. A similar way, I want to show you other things here. So once let me see if there is any topic which is missed. So forwarding table, routing table is covered. Okay, you know how to enable the debug. It's IPBGP all and IPBGP IPv4 unicast updates. Okay, and regarding those states, idle and active, so you will see in this way. Okay, so this happens when your neighbor is going down. Okay, I can do that, but we have to wait for 3 minutes because the hold timer for BGP is 180 second, which is 3 minutes. Okay, so if I bring down one of the neighbor, then we have to wait for 3 minutes to see them going to active state. Okay, so if you see, so let me show you how can I reproduce such scenario. So might be later on you can try it. Okay, so let's say you go to the interface 0/2. Okay, so it's 0/2, and if you shut it down, so if you shut it down, you can see from this router point of view, it immediately detected that it's down. Okay, so you can see it's in ideal state immediately. But from the second router point of view, sorry, summary command, you will see they are still happy, or there is happy neighbors, right? They are still happy neighbor with so and so prefix. So why is it so, and how much time is going to take for this router to declare that this router is down and the neighbor should be discarded? It will be your 180 second. Okay, that is why I said we can reproduce it in the lab, but we have to wait for 3 minutes for to see that change. Okay, how where do I come to know that it's 180 seconds? So let me come here. If I say show IP BGP neighbor, okay, so it's gonna give me lot of details. If I filter it out, so it's 180 second. Okay, keep alive is 60 seconds. So 3 consecutive hello packets, let's say the first one, okay, on 0, the second on, okay, so this way. Okay, so the first one on, okay, give me a second. So let's say first one on 60th second, the second hello packet on 120, and the third one on 180. So that is when they will declare themselves to be down, and you can see now that BGP has gone down. Okay, so if you see from this side, so this is already down. What about on this side? So you will see they are on idle state. Okay, one more thing that I wanted to show you over here. Okay, fine. So do we have debugs? Okay, so I'm having debugs. Okay, I'll show you some packets. So you can see active went from idle to active. Okay, so someone who had the active role now went to idle state. That's what this bug, or that is what this debug message is informing us, that one of the active router. Now which is that active router? Is it router 1 or is it router 2, right? Now let me also bring this. Okay, so let's say I bring up this, so by no shutdown command, let's see what happens. So you see there is a passive, right? So it proves that these two routers are forming in active and passive relationship. Okay, that doesn't mean that one is serving, one is not serving. It's about forming the neighborship, or who is going to send or who is going to initiate the conversation. Okay, so when I have A and B, one has to initiate the hello, or one has to initiate the BGP conversation, right? So one will be elected as active, the second one as standby. So the lower root ID will win the election. It will be called as active, and the higher one will take up the passive. Okay. Now there is one concept behind this active and passive, which I'll show you with the help of Wireshark. Okay. So if I go to my Wireshark, so do I have the latest packets? I see there are lot of packets. Okay, how do I prove which is active and passive? So we can get lot of information here. Okay, so if you see this 201.1, that is your first router. Okay, the first router 201.1, what is the port number it's associated with? It's associated with 179. So I can write in this way, right? We can write IP and colon and the port number. So on the other side, the router has IP 201.2, and what is the destination port number? 35689. Do this remain in the same fashion? So let's confirm that. So let's check out on the different packet where it started with dot 2. So when it start with dot 2, what is the port number? So port number is 37689, and on the destination side where you have 201.1, what is the port number on destination? So destination is says 2179, right? So what do we understand? So you see it's having a universal tagging or universal port tagging. So I can just summarize: 201.1 always has port number 179, right? Over here you had 179. In the second packet also you had the similar behavior. This can be destination, this can be source. I am not telling packet will be originated from source to destination, or packet is I am talking about active and passive now. Okay, so as of now this IP is always having 179 as a listening port. You can check any of the packet, the source or not source, the pack 179 will be associated with this IP. Okay, so let me show you few more examples. If I go to the third example, third packet, so here source is 201.1, again the source port was 179. If you go to the topmost or one more packet, so now you see 179 was shifted on the destination side and it's again tagged to 201.1, right? So that is why I have written it here. that 201.1 is having 179. That can change in any order, but as of now 171 is associated with this IP, and this IP we know it's our R1. Okay, so 179 is associated with this side of IP, and on the other side it's this 35689 port. Okay, on the other side. So now let's see what is active and what is passive. Okay, so if I take back to my PDF, so you can see this. The neighbors will form they will have the active and passive election internally, and the one with the lowest BGP will actually establish the connection. So that is the only relation of that's the only purpose of active and passive. Okay, it's not about that active will serve the traffic and passive will be sitting idly. This is not the standby or failover concept. Okay, both are serving the traffic, but it's about who is establishing or who is uh, saying hello first. Okay, so the lowest one will say or will begin the conversation. Okay, and in the case of active and passive, the active will always be greater than this port number. So if you see in my scenario, this is active. Okay, so this is active as of now. That could be because I initiated first router and the second router was initiated later. So I can reset them with the help of clear IP BGP star. Okay, with this command I can reset the process and I can elect. Okay, so that is a different story which we can do it and we can see, but I'm talking about active and passive thing. So active is in this case this second router, you have this port number which will be greater than 103, and passive is always gonna be 179. Okay, so this is passive now. So this is a passive which is always on 179. That is a known thing in BGP. So that is what I included this. Okay, now active will be called as client, this is called as client, and this is called as passive. Oh sorry, this is called as server. Fine, this behavior now can be modified. It's not really important, but just telling it from your BGP point of view that what BGP is capable of. Okay, not trying to make it confused. Okay, so don't take it in that way. So just how can I see the values. Okay, so let's say how do I see the counters or from on the router point of view. So if I do see show IP BGP neighbor host, so you can see 201.1 is on this local port. Okay, this is the port, and on the other side you have 179 added up, or that's acting as. So this is a command where you can, let's say if you don't have Wireshark, so in that case you can also check it from your CLI. So don't get confused here, because this middle person is having neighborship on left and right as well. So just focus on one of them. Okay, so this is in case you don't have access to Wireshark. If you have Wireshark, Wireshark is much better uh, in order to analyze the things. Okay, fine. So now regarding the modification, we can modify the change. Okay, so let's say if this was passive and now you want to make this as active, so you can do the configuration. You can make use of this, and you can say you are a passive and I am active. Basically this is not required, this is actually in depth of BGP. Okay, in normal scenario we just configure, we just set it up, so it's not really required, but yes, to know what is the level of BGP, just giving you all that corner informations. Okay, fine. So that was regarding active and passive, which will be done automatically in the backend. We don't have to do anything, but if we want to do some changes, we can do the configurations. Okay, the one next is BGP timers, which I have almost discussed. So the two important timers here are keep alive, hold down. So this is keep alive, and the hold time or dead time are always into 3 here. Okay, so 3 consecutive packets keep alive. If they are not answered, then the other or the neighborship will go down. Okay, so this is the command to see the neighbor relationship. Both timers can be changed. That's true. We can change the timers. Okay, we can change the timers in two ways actually. One is universally, second is interface basis or neighbor basis. So let me tell you in this way. So let's say I have one router, this is one more router, and I have another router here. So I have this in one AS, the second AS, and one more third AS. Okay, so I can configure or I can change the timers between these two and keeping rest on a default. That's 60 and 180. We can keep the default over on this. Same time, I can change this on a neighbor relationship basis or on a basis of neighbor. I can make it as 10 and 30 because it's into 3. Similar way, if this router is forming neighborship with another router, now you can go with very critical timings also, that is 1 and into 3, which is 3. Okay, so we can do it on basis of neighbors, or we can also keep it on basis of default or entire topology. I don't say it default because I can do in this way. Let's say I keep universal not in 60 180 but 20 and 60. This is my universal. Okay, with all the routers, but one or two routers, one or two neighbor routers, I want to keep it as 10 and 30. Might be second neighbor, I want to keep it as 1 and 3. Might be the third one, I want to keep it as 5 and 15, right? So we can do it in this way. There's not a big deal. How do we do is, we go to conf t, I go to router BGP 65000. Okay, it says one more important thing which I just recalled. You can have only one BGP process. Okay, you can have only one BGP process. If you try to run another BGP process, second BGP process, it says that the router is already running on one of the AS, so you cannot run the second process. In case of EIGRP, OSPF, you could have run multiple instances, but in BGP, it runs only on one instance. But let's say you are on a VDC context, okay, virtual context, where the whole router is divided into multiple virtual contexts. This is given to customer A, this is given to customer B, and so on. But whole together in the back end, they are a single box. Okay, they're logically dividing it. Now in this scenario, you can run multiple, let's say, individual BGP process on individual VDC. So this will have one, this will have one, this will have one, this will have one. So again, they cannot have 2 or 3 of multiple, they can have only one each. But a single box, multiple VDC, and each VDC one single BGP process. But since now this is a single box, I am not configuring VDC, so I can only make use of one BGP process, no more than one. Okay, so I have to go to this AS, and to change universally, this is the command. I say BGP, I can keep alive to be 1, and I can keep the whole timer to be 3. The best is into 3. Okay, but also remember that the whole timer is letting you to configure 0 1 2 as well, right? So the best practice says that hold timer don't configure below 3. So this is a best practice. Don't keep it below 3. Okay. So might be a single packet can lead to neighborship loss, right? So at least keep it into 3 always. So lowest that you can have is into 3, because if you have one acting as your lowest hello, then into 3 would be your the lowest value that can have, right? If you keep 0 as your hello timer, then your whole timer is also be 0, right? So in this case that's not practical. So the best practice say that keep dead or the hold at least 3 seconds, not in 1 or 2, okay, to avoid the continuous flaps or fluctuations. Okay, so this is one command to keep universal. What is by default the timers are, the by default the timers are 60 and 180, right? That timer you can keep it as 1 and 3. Similar way, as we discussed about on a basis of neighborship, you can do that as well. So let's say you have neighbor who is 1.1.1 and you want to change the timer, so you can say the keep alive you want to keep 10 and whole timer you want to keep it 30, right? So this is the way to configure in the case of per neighbor basis. Okay, two ways to do that. One is centralized or changing the default behavior, and the second one is on a per neighbor basis. Okay, so value of 1 or 2 are illegal, don't keep it, just make use of minimum 3. Okay, so these are few commands where we see the whole timer and keep alive. Okay, so the last topic for the day, that is BGP next hop self. So as we discussed earlier, next hop is nothing but the next immediate router which will help me to send my packet to the destination. Now destination can be 4 hops away or 5 hops away, I'm not bothered about that. Okay, as a first BGP router, my uh, database should know that this is my immediate or this is my next hop, and then this will take care of remaining things. Now we are talking about different concept. Okay, next hop self. Now what happens is, in the case of eBGP and in the case of IGP, oh sorry, IBGP. So what happens is, whenever I'm advertising a packet from AT&T to Vodafone over on eBGP, so those packet, let's say 4.4.4, I advertised 4.4.4 to this guy. Now I'm setting the next hop as this interface IP. Okay, dot 1. So that's default thing. Let's check it out. Okay, so let's check it out on my router end, what I'm trying to say. So let's see on the third router. So let me get them on top. Okay, so from this router point of view, if I do see show IP BGP, so I have 209.209. Okay, so there is something missing. Okay, I also have to see 165 IP. Okay, so let's see what is not configured. So I have this 201.2, I have 209.209. Okay, on the second router show run session BGP, I have the neighbor with 13.2 and 201. Okay, and the two networks here are 209. Okay, so the network advertisement, I'll keep it here. Okay, so let me also clear the process. So this is how we clear the process. Okay, this command, clear IP BGP star. So where is 2009? So it's on this router. Okay, this is the loop back. Okay, so I have the route that I am actually looking for. So I can show you the uh, example for the next hop self. So if you see, as of now, the normal behavior of BGP, this is my route 209 209 2090. So what this router did is, while advertising this network to this second router, it said that this is a next hop. Okay, this is a next hop IP, or this is a next hop, which is dot one. And now this router, while advertising to its peer, which is on IBGP, it still kept the same IP address, right? It's still keeping the same IP, that is 209.165.201.1. Now that can be a mess when, let's say, you don't have any IGP, you don't have OSPF, you don't have EIGRP internally within IBGP scenario. Okay, and now there is no way that this router know how to reach this gateway, which is far away. They are not directly connected, they are 2-3 hops away. And let's say your IGP fails, your one of your IGP protocol fails, right? That can lead to the outage. So what I do is, I change the behavior of this. I change the behavior of BGP, and I say, while advertising this network, which is 209, to any further, don't keep this as a next gateway. Instead, keep yourself as a next gateway. That is why it's called as next hop self. Okay, next hop now is not this IP, instead it's the self IP. Okay, so I'll do the change now. You see what happens on this entry. So as of now, it's on some far away hop, might be four hops away. Okay, and if there is no IGP, there is no OSPF, there is no way the router C can reach this, right? It's far away, and if the IGP fails, or if you have not advertised properly, your packet will not know whom to send, right? I'll show you that example also. So let me show you as of now what happens if I do show BGP and this network. Okay, so it says it's inaccessible. Okay, because I don't have any GP in my scenario. I don't have any IGP, so there is no way that this knows how to reach back. That's why it says inaccessible. If I do simple trace route to make sure whether this is sending a packet forwarded or no, I can do that as well. So let's say I'm trying to trace route this. I'll remove the other commands and I'll place a trace route. Okay, router C don't have an idea whom to send. Okay, it's just gonna drop them. It's inaccessible. Okay, so that's the normal BGP behavior, not BGP. I can say it's a normal IBGP behavior. internal BGP behavior, that while advertising, it's not gonna change the next hop, it's still going to keep this as a next hop. Now that's something which I will change it, okay, which I'll go against the BGP default rules. So I'll close this. I'll go to the second router, because that second router is the culprit here, who is not doing his job, right? So I'll go here and I say router BGP 65001, who is the neighbor as of now. So from this router point of view, while sending any update to this neighbor, which is dot 2, keep myself as next hop gateway. Okay, so let's do that. Neighbor 101.172.13.2 next hop self. Okay, I'm going to be the self for you, and then press enter. Okay, so it will be not immediate. You have to do clear IP BGP process. And now if you go here and if you check, the behavior would have been changed. Now it will be not in this state, neither the next hop would be some far away hops. Okay, so let's see what happens. So if I do see show IP BGP, now the next hop is been reduced to the directly connected router. Okay, now from this point of view, this is not a next hop. Instead, this router 2 act as a next hop. You see this 10.172.13.1 is acting as next hop. Now let's see from the accessible point of view. Okay, so I'm going to check this, and if you see now, the word inaccessible is been taken out, right? So previously there were a additional word called as inaccessible. Okay, it had no clue how to send that packet towards AT&T. Okay, now as soon as I said I changed the behavior, now this is acting as next hop. I can do trace route. Okay, I don't care if it goes towards destination, but I will see if my packet knows whom to send it. That's the main thing. Okay, I'm not trying to get end-to-end connectivity. I'm just trying to see if my Vodafone router 28 knows whom to send it. Now that's up to the second router. Then if it knows how to go back to AT&T or no, that's a different story. But let's see by doing trace route. Okay, when I do trace route, you can see it's going towards second router or Vodafone 27, and since there is an active BGP, you can see they are reachable as well. So if I ping now, they are reachable, right? So this is the scenario in case of iBGP. So by default, iBGP, what iBGP does is, whenever a router, whenever the iBGP router is learning a route from eBGP, okay, so this scenario arises when we are dealing with multiple AS. Okay, so if one autonomous system is advertising its network to the starting point of this eBGP, and this router will now act in a default BGP concept. Okay, and as per the concept, it says that it's not gonna change the gateway while sending to its iBGP peers. Okay, so it can be multiple iBGPs. What is the gateway it's gonna include? It's gonna include this. Okay, so all your advertisement, if you open up and if you run show IP BGP, you're gonna see the next hop to be some far away gateway, which is 4 hops away, right? And if you don't have internally any dynamic routing protocol, there is no way you can reach that, right? So there are two ways that you can deal here. One is you can make use of IGP like OSPF or all those things inside your BGP landscape, but you know what is going to happen. You're going to increase a lot of overhead on the routers unnecessarily, just for sake of advertisement. You're running or you're hitting on your memory resources. So the best alternative, or the second alternative, is to change that default behavior of BGP by activating next hop self. So what it does is, the router which is gonna receive the prefix, it's gonna add its own gateway now. Okay, it's gonna add its own gateway and then give it to its internal routers. Now routers individually, the IBGP routers, now they don't have to worry about this. They just have to send it to this gateway, which is one among them, and now this one will be forwarding it back, right? So this is called as BGP next hop self concept. Okay, so in very simple, next hop is nothing but when a BGP is sending a packet to a destination which could be multiple hops away. Okay, so it don't care about the third, fourth, or the destination. It will only see who is the immediate next hop. So this act as a next hop. This router will see who is the next hop, it's here, and so on the packet reaches. Okay, so next hop is nothing but the next immediate router to reach that destination network. Okay, and the next hop self is when you have multiple AS numbers. Okay, and your advertisement are going between two different autonomous system, and now the receiving router will not gonna change the gateway by default. Okay, by theory it's not gonna change the behavior. It's still going to keep the gateway which is far away, which is from the other autonomous system. And if you do not run any IGP, these individual IBGP routers will not know how to send, whom to send. Okay, so what I'm going to do is I'm going to introduce this concept of next hop self. So what it does is, this router, while advertising, it will say that I am your next hop now. Okay, I am the next hop, so you guys have to send me, and then I'll take it forward to the AT&T router. Okay, so little bit theory that I have added here. So whenever you go back and read this, you get this. So this is RFC. It's one of the well-known mandatory path attributes. Okay, so while going across this flavors, so there are like 4 flavors: well-known mandatory, well-known optional mandatory, and other couple of 2. So those 4, totally 4, like 1, 2, 3, 4, these 4 will have totally those 13 attributes. Okay, so the first one would have 5 attributes, the second one have 3 attributes, and so on. That's how they're categorized, right? So this next hop self is part of one of the category. Okay, it could be this, it could be this. I don't want to bring that topic now and confuse. We'll keep this for the next class, but just giving you an overview where this fits. Okay, it fits in one of the attribute. So basically the first one where it's a mandatory well known. Okay, so what is next hop? Next hop is well known mandatory attribute that defines the IP address of the router should be used as a next hop. Okay, this should be used. IBGP, in case of IBGP, I'm not talking about eBGP, IBGP, they do not change by default. Okay, the IBGP, this is gonna be taken forwarded. That's something which I have to solve. So basically this is the solution. The BGP next hop attribute is the next hop IP that is going to be used. IBGP do not modify it, it's going to leave the original value. Therefore, when the router performs a route recursion, okay, route recursion or recursive route or looking up or lookup are the concept in BGP where it will check the routing. Okay, so it's gonna see the routing. It's gonna see. So let's say I have one site, and this site is connecting to this ISP, and this ISP is connected to another site, but that site has two routers, R1 and R2. So this router will make the recursive lookup whom to send, whether to R1 or to R2. Okay, so that's a internal part of BGP, recursive route lookup. Okay, and that is what we manipulate with the help of path attributes. We can say this has to not go with recursive lookup. Instead, I'm going to uh, hard code path manipulation so that it always check R1, right? So that is possible. But if path attribute is not done, then it will do the recursive lookup to see the next router to send. Okay, so while doing the lookup, if there is no IGP or there is no OSPF or something, so basically what is happening, it's going to send it down. Okay, so if I show you over here, okay, let me show you from this show IP BGP or show route. So you have 1.1 network, show IP BGP 1.1.0. Okay, so from this point of view there is no problem. Okay, if you see from this point of view, there will be no problem because they have done it right way. The problem was from this side because this has not done its job. This person still kept this, and now when it's time for this person to send back, there is where the issue comes, and there is where you get the next hop concept, next hop self. Okay, these are the configurations while you doing the lab. So one single command that will bring up the change. Okay. Okay, and yes, clear IP process is very important, which I'll include it. Okay, without that you will not see the process updates. Okay, so that's all from my side. I'll take Q&A and we'll wind up for the day. So where is, if you guys have any doubts, you can unmute yourself. Okay, so we have this updated or modified. Okay, so this update, okay, this update is as I told you, I've only changed the icons. Okay, the only the icons. The rest are same. If I minimize this, you can see there is no major changes. They are already present in your present lab topology. I've just changed the icons, but don't worry, I will give this after the class with the icons. Okay, might be you already have the icons. So the way you change, you need to change this. So let's say I have one of the router here. Okay, I right click on this, I go to change symbol. I must have some customized icon which you can get from Google or you can get from my Google Drive also, which I've shared it back. So just click on the symbol that you need and just click on OK, and that will bring up the change. Okay, so that is only the change I have done and nothing else other than the IPs which I said that they are configured, which is mentioned again on the PDF. Okay, so on the PDF, if you go, okay, I think I gave you the notepad for this, if I'm not wrong. I guess I gave you the notepad on which was pasted on the WhatsApp group. So what are these? These are for OSPF. So this is BGP. Okay, so these are BGPs. Okay, so I've given this already, but yes, I can give you once again. So those are the initial IP configurations. Okay, which is again visible on the screen. So that's one for your question. Okay, so actually you're a little greedy, I can see. You are talking about your own laptop, right? But if let's say you want to communicate from your laptop to my laptop, if we talk in little broader way, you sitting on your side or a different part of the world and I sitting on one side of the world, if we both have to communicate, so our application should take should rely on some protocol. Okay, the protocol which can take your data to my laptop and my data from my laptop to your laptop, right? So we need a WAN phasing protocol. That is where the BGP comes. Okay, within the laptop, within the multiple application, if they don't need internet, I can just set up a normal LAN. Let's say I'm playing a online game, or not online game, let's say some LAN game like Counter Strike. So do we need internet for that? Do you think we need BGP for that? It's just matter of setting some IPs on a single network and just connecting 4 5 laptops and playing Counter Strike, right? This is when you need internet as a intermediate carrier, right? The transport carrier who will take your data from your laptop to my laptop. Okay, so that's where you need BGP. Otherwise, you don't need BGP. So I can say BGP is running or BGP or your internet is all consisting of these BGPs or the WAN protocol. Okay, if no internet, no need of BGP. You it's all about LAN only. Fine. Okay, so I'll guess I did some mistake in the mask. I guess this was in during the loop back, right? Okay. Okay, I'll share the Google Drive, not an issue. So this is Google Drive. You have some icons from my side. Okay, so these are few icons and rest are all so these are some good things. iOS and EVNG, you can get it from online. I don't say to download from here because they are pretty older and after all community version, so which you can prefer from official. Again, this is a GNS which is 2.2.3, pretty older. The latest one is 2.2.8. Okay, which you can again get it for free from GNS website. Packet tracer, once again it's from Cisco website. Okay, the reason I included is it's little complicated to go to Cisco website and register and get it. Okay, so that's why I downloaded it and kept it. And rest is VMware, which again you can get over on the website. It's free. Okay, so what I'll do is I'll share this whole Google link with you guys. Okay, so I don't have WhatsApp running at this moment, so I'll do it after the class. Okay, the whole folder I'll share it. That's not an issue. Okay, so there is a catch here. Okay, application is not a BGP. Application is initiating a process of BGP. You're getting that catch here. Your application is just a application which is working on the TCP protocols or UDP protocols. So let's say you have some VoIP like Skype. you have your browsers like Google Chrome. Okay, you have some whatever internet facing applications, right? So they are not going to create individual BGP sessions. Okay, because these applications are dependent on the NIC card. What is NIC card? Let's say on your laptop or on your computer there would be a chip, okay, which is called as NIC card, network interface card. This NIC card has some mechanism to connect with your routers. Okay, so there can be Wi-Fi connection or they can be wired connection like RJ45, and all these applications which are inside your laptop will send the packets to this NIC card. NIC card will initiate or will establish connection with your router which is inside your home or inside your office, and this router will be the point which connects to ISP. Okay, so this is how your only single BGP process initiate, not multiple BGP process initiate. Okay, your application are initiating the process. It's not that your application is initiating individual BGP here, and then that's why you say that why 10 BGP process are not getting initiated. Okay, so if you talk from the OSI layer point of view, you have application, presentation, session, transport, network, and data link, and physical link. Okay, so these three topmost layer are within your laptop. Okay, so application, as you said, 10 different applications. The presentation will convert those application to respective binary values. So let's say your text gets converted to ASCII. You have image that gets converted to JPEG. Okay, you have audio that's get converted to MP4. That's a work of presentation. It's again inside your laptop. Then you going to create a session. So what is a best example for session? That's your browsers. Okay, so I have multiple session open. So I have one session, two session, three session, four session, right? Multiple session. So again, it's on my laptop. It's within my laptop. It's not out of my laptop. Okay, one second. Okay, so after these three, the topmost three layers, that's when your hardware layer starts, or your network or your actual packet flow starts. Okay, so depending upon the traffic, so let's say traffic from a VoIP application gets classified to be UDP. Application like HTTPS gets classified as TCP, and they get their header, they get added up the port numbers, okay, for the reliable communication, end-to-end communication, windowing, sliding, all the other features they're gonna send to network. Is where your IP to IP or the forwarding will happen, then goes to data will add the correction mechanism, and then go to physical will then go towards the cables, and on the receiving side the decapsulation happens, and they are seen once again on your uh, on the laptop. Okay, end to end process. So your applications are actually initiating the BGP process, which is now flowing across internet. So it's not that you have 10 applications, so you will see 10 BGP session creating. So your laptop is not initiating it. It's your router that's gonna initiate the BGP. Okay, so if any further doubts? Okay, guys, so see you, and we'll meet up in the next class. So I'll pass on the PDF, I'll pass on the Google Drive, and also I'll get you the topology, the new one. Okay. So signing off for now, and have a nice day. See you in the next class.